look at some examples for solving for a variable. So the first thing you need to know is solving for a variable is going to be very similar to solving an equation that only has one variable. So here we have some formulas or some literal equations that are not formulas, and they have multiple variables in them, and they in the instructions say to solve for a specific variable. So the first one, this is a literal equation, and it says solve for b. Always pay attention to which variable you're solving for. So what that's asking you to do is create an equation that has b all alone on one side, and on the other side we're not going to get a number like you would when you were solving a regular equation, but you might have numbers. You'll have an expression that equals that b. So it'll have the a, maybe, probably, we'll have some numbers. It'll just be something that represents what b equals. Okay, so one thing that might be helpful is to highlight the variable b, because that's the one that we want to get alone. So think of that like what you were solving for before. One strategy I tell my students is for the other variable, I want you to think of it like a number. So this a, pretend it's a number. It's not a variable to you at this point. You know, it's a variable, but just pretend it's a number. So if that's too hard to do, then pretend that you had a number in there, like 2 times a, so let's say it was 2 times 5 plus 3b is equal to 12. Okay, so then this would be like a 10 plus 3b is equal to 12. So then ask yourself, now remember I just made this up. This isn't really what's happening. It's just to prove a point. Okay, ask yourself what you would do first to solve this. The answer would be move this to the other side, subtract 10 to the other side. Okay, so keep that in mind. That's what you had to do first. Well, that's what we have to do first in the actual thing, but let's go back and kind of erase this and actually do that. So the first thing I need to do is get rid of this 2a. I'm going to subtract it, the whole thing, a 2a from both sides. Okay, so it's gonna, these are gone now because I'm basically moving it to the other side. Now really important, 12 and minus 2a, those are not like terms. So I cannot actually turn that into anything that I can, like a 10a, or that's not true. How you would write that is you would say 12 minus 2a. You could also, another version, you can do negative 2a plus 12 because those are equivalent, but this is fine. Bring down the equals and the 3b. Okay, but we're not done because we didn't get it to be b equals. We got it to be 3b. So we need to get the b all by itself. So I'm going to need to get rid of this 3. So what I'm going to do is I'm going to divide both sides by 3, right? How do we undo multiplying? We divide. All right, so over here when I divide by 3, you could write it like this. But then you can also sort of divide up that 3 and do 12 over 3 minus 2a over 3. And then you can reduce the 12 over 3 is 4 minus 2/3 a. And then on the other side we have now just b equals, and this is what we wanted. We have b equal to some stuff. It's an expression that has numbers and a involved. Okay, why don't you try number 2? Well, actually, number 2 is a little bit challenging. But go ahead and try it, and then we'll talk about it. So pause the video, give it a try, and then we'll talk about it. Okay, so what makes this one challenging is that there are 2 y's here, because that's what we need to solve for. Y. There's a y in that term, and there's a y in that term. What? Okay. Then We need to get it so that it's y equals all by itself and then equal to some stuff, just like from before. Okay, but so what we need to do is we need to get the y's together. Okay, so what we're going to do is what I call the opposite of the distributive property, or the backwards distributive property. Imagine you had something and there was a y on the outside and it distributed and it gave us 2y plus xy. Well, we want to undo that distribution. So I'm going to write it like I just have right here, y, and then in parentheses. And I want to think about what was inside here that gives me 2y plus xy. Well, you kind of have to divide or think about what multiplied to give you 2y. Well, y times 2 would give you 2y plus y times an x would give you x times y. Okay, equals 4. So remember, I want to get y all by itself. So by doing that, I only have one y now. So now that y is being multiplied by 2 plus x, and that whole thing in parentheses. So we have to undo that. So we're going to divide by 2 plus x to both sides. 2 plus x divided by 2 plus x will cancel. So all we have left is just a y, this y, equals 4 divided by 2 plus x. And this is our answer. All right, let's take a look at some formulas now. Here we have the area of a triangle, and we need to solve for h. So we need to get h alone. So let's see, what's happening to the h? Well, we're multiplying it by 1/2, and we're multiplying it by b. So this is all multiplying. Okay, so let's get rid of each of these at a time. So let's start with the 1/2. Anytime you have an equation with a fraction and you want to get rid of that fraction, think about multiplying by the denominator. So the denominator here is 2, so I can multiply both sides by 2. The reason this works is that denominator will cancel. So I have 2a equals b times h. I don't need to write the 1. I mean, I could, but 1 times b times h is just b times h, so it's unnecessary to write 1 times a variable. Okay, so actually I'm going to clean that up because that just makes it a little messy. So it's 2a equals b times h. So then I still need h alone, so I need to get rid of the b. It's multiplying, so let's divide. Gone, gone. And here's our answer. H equals 2a divided by b. All right, your turn. Go ahead and try example 4. This is the perimeter of a rectangle, and solve for w. Did you solve for w? Not yet? Okay, pause the video. Okay, let's take a look at the answer. So we needed to solve for w. W stands for width, it's over here. So we need to get rid of the 2L term. So I subtracted it from both sides. You can't actually subtract p minus 2L and get something, so I just wrote it as p minus 2L. Okay? If they're not like terms, that's what you have to do. Then I had to divide both sides by 2. So these 2's canceled. And then I split up my fraction, so it's p over 2 minus 2L over 2. So each one gets that denominator. These 2's cancel, and there is my answer. It could also be acceptable to write it without splitting up the denominator. So like this. Those are fine. Both of these are good. Okay? All right, good job.